Hey guys, so today we're going to do this problem 6.5. So it gives you a little diagram of a saw, and the question tells you initially the motor on the circular saw turns the drive shaft at omega is equal to 20 t to the 2/3 radians per second. T is in seconds. If the radii of gears A and B are 0.25 inches and 1 inch respectively, determine the magnitudes of the velocity and acceleration of a 2C on the saw blade after the drive shaft rotates at theta is equal to 5 radians starting from rest. Okay, so this problem can seem a bit intimidating, mostly because you're given this diagram and a couple gears and told to go for it. So I'm just going to try and explain a bit more what's happening. So gear A is getting powered, and it's transmitting its power to gear B. Gear B is located at the center of this whole saw, and gear B is powering the saw. C is a little saw blade on the saw. It's a saw tooth, and it's being rotated by B. So the question gives you some information. It tells you omega is equal to 20 t to the 2/3. It also tells you RA, the radius of a gear A, is equal to 0.25. It says RB, radius of gear B, is equal to 1. It asks for VC, so that's what you're looking for, the velocity of this. And it's also asking for AC, the other thing you're looking for. And it's looking for these at a point when your rotation, theta, is equal to 5 radians. It also tells you in the diagram that your radius C is equal to 2.5 inches. These are all in inches. So, before I get started, I want to make sure that everyone has some background in gears. So essentially gears transmit torque and power, and their gear ratios tell you what's getting transmitted. So first of all, this is true, omega A RA for gears. So the angular acceleration of gear A times the radius of gear A is equal to the angular velocity, of these times RB. I was getting a little bit ahead of myself because the angular acceleration times RA is equal to the angular acceleration of B times RB. So these are both true for gears, and they'll come up a lot. So to start off this problem, we know that we have omega, and with omega, it's pretty easy to find alpha, so we're going to do that first. So we know that alpha is just the derivative of omega, so I'm going to take the derivative here. So dw dt equals alpha, and the derivative of 20t to the 2/3 is equal to t to the negative 1/3 times 40/3. Okay, so now we have alpha, and one thing that we don't have that both omega and alpha are dependent on are time. So there's actually a way we can find that. It gives us theta in the question, and we know that d theta is equal to omega dt. So if that's true, d theta is equal to omega dt, then integrating both sides will give us theta equal to, the integral of omega is, let's see, t to the 5/3 times 20 stays here, and we're also multiplying it by 3/5. So we know theta is equal to 5, so this actually allows us to solve for t. So solving for t gives us 0.5914 seconds. So, not very big. With t, we know omega in terms of t, and we know alpha in terms of t, but it would be nicer to know them definitively, so just plugging in for 0.5914 as t, we find our angular velocity to be 14.091, and our angular acceleration at this time gives us 15.885. This is in radians per second, and angular acceleration is radians per second squared. Okay, so how does this help us get VC and AC? Well, we have relationships for both, but I should have mentioned this omega is omega A. So omega A is here, alpha A is here. So we know omega A and alpha A, but we don't know omega B, and omega C are going to be the same just because B is located at the center of the whole wheel. So we're going to go use these relationships to find omega B and alpha B. So we know omega A RA is equal to omega B RB. So omega A we just found, it's 14.091, and we're given RA in the question at 0.25. We're also given RB as 1 inch, and we want omega B. So rearranging and solving, this gives us 3.523 radians per second. Now, doing the exact same thing, but for alpha, will give us the angular acceleration of B. So we just solved for the angular acceleration of A. It's 15.885. Radius of A is again 0.25. Omega B is the thing we're trying to find, and RB is 1. So rearranging this, we can find that omega B is equal to 3.9712. Okay, so now we have omega B and alpha B. But the final things we want are VC, so the velocity of C, and the acceleration of C. Well, this is the same thing we've been doing this whole time. So we know that our velocity is equal to omega r. So in this case, it's the velocity of C, the thing we're trying to find, is equal to omega B and omega C are the same. So it'll be omega B, and this is going to be RC because they're not different. RC is 2.5. So using this, we already found omega B. It's 3.523, and RC is 2.5. So all of this is equal to VC, and we can find that VC, our velocity at C, at theta equals 5 radians is, let me plug this into my calculator, 8.81 inches per second. Now, this is one of our final answers, and we have 2 more things to find. It wants the acceleration at C, so acceleration tangential is alpha r. Acceleration tangential of C is alpha b, because again they're going to be the same, RC. That gives us alpha b was 3.9712, RC was 2.5, and our tangential acceleration of the of the saw tooth is 9.928. Just as simply, acceleration normal is omega squared r. This is omega b and rc. This gives us 3.523 squared times 2.5. We have a normal acceleration of 31.025. Now the question actually asked for the magnitude of the acceleration, but that's not too hard. So that just means that our AC is equal to our acceleration tangential squared plus our acceleration normal squared, all square rooted. And if you plug that in, it gives you 32.6 inches per second squared, and that is your other final answer.